Welcome to the DIY Honda Garage channel. This presentation covers diagnostic trouble codes P0201 and P0204, which pertain to injector circuit malfunctions in the Honda CRV models spanning from 2017 to 2022. DTC P0201 signifies an issue with the number 1 cylinder injector circuit, while P0204 indicates a malfunction in the number 4 cylinder injector circuit. These issues can arise from a variety of factors, including wiring problems, relay failures, or sensor malfunctions. Diagnosing these codes effectively requires a structured approach to troubleshooting. Each step outlined is essential for pinpointing the exact cause of the issue, ensuring the necessary repairs can be made to restore the vehicle's performance and reliability. DTC P0201 indicates a defect in the number 1 cylinder injector circuit, while P0204 points to a problem in the number 4 cylinder injector circuit. The critical components involved in these circuits include the fuel injectors themselves, the powertrain control module, PCM, and the associated wiring and connectors. The fuel injectors are located in the engine cylinder head, where they play an essential role in delivering fuel precisely into the combustion chamber. The PCM is situated in the vehicle's cabin or engine compartment, depending on the model, and regulates engine functions, including injector operation. Correctly diagnosing these DTCs requires access to the vehicle's diagnostic system to read fault codes and monitor circuit functionality. Several factors can trigger DTC P0201 and P0204, predominantly revolving around electrical issues. Poor connections at the injector terminals or the PCM can disrupt current flow, leading to circuit malfunctions. The injector relay, which supplies power to the injectors, may also be faulty, thereby failing to activate the injectors when required. Additionally, compromised wiring, such as breaks or shorts within the harnesses, can cause these trouble codes. Understanding these potential causes is pivotal to direct the troubleshooting efforts effectively and efficiently, ensuring a thorough examination of the vehicle's electrical system. The presence of DTC P0201 or P0204 may manifest through several noticeable symptoms in the vehicle's performance. One of the most critical indicators is the engine's failure to start, which can disrupt daily operations for the vehicle owner. Furthermore, if the engine does start, it may exhibit misfiring or a rough idle, indicating that the fuel delivery to one or more cylinders is compromised. Often, the check engine light will illuminate on the dashboard, alerting the driver to a fault. These symptoms can significantly impact drivability and should be addressed promptly to avoid further complications. The first step in troubleshooting DTC P0201 and P0204 involves verifying the presence of the problem. Begin by turning the vehicle to the on mode without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. After clearing, switch the vehicle to the off mode and attempt to start the engine. If the engine fails to start after cranking for up to 20 seconds, examine the HDS for any pending or confirmed DTCs related to the injectors. This initial step is crucial for establishing a baseline and ensuring that the DTCs are current rather than lingering from past issues. The second step focuses on the engine starting condition. Attempt to start the engine again after following the previous step. If the engine starts successfully, then proceed to step 10 for further diagnosis. This outcome can indicate that the fault may have been transient or resolved. Conversely, if the engine does not start, this could point towards a more persistent issue that requires deeper investigation, thus directing the technician to proceed to step 3 for additional relay checks. Understanding the engine state post-attempt is vital for guiding the diagnostic process. In this step, the focus is on examining the injector relay, which is crucial for electrical supply to the fuel injectors. Begin by turning the vehicle to the off mode and then remove the injector relay for testing. Proper functionality of the relay must be confirmed, as a malfunctioning relay can prevent sufficient power from reaching the injectors. If the relay is found to be in working order, you will proceed to the next step. If not, it is necessary to replace the faulty injector relay. The reliability of the relay greatly influences injector operation. Thus, its evaluation is essential in the troubleshooting flow. Step 4 involves checking the FI main RLY outline to ensure that it is intact and capable of transmitting voltage. Begin by turning the vehicle to the on mode while ensuring the injector relay remains disconnected. Measure the voltage between the designated test points on the injector relay socket and body ground. If battery voltage is present, it indicates that the FI main RLY outwire is functioning correctly, facilitating the necessary power supply to the injectors. If not, this suggests an open circuit in the wiring that you will need to repair between the powertrain control module, PCM, and the injector relay. At this stage, the focus shifts to checking the +B in-J line for continuity. Start by turning the vehicle to the off mode and again ensure the injector relay is disconnected. Measure the voltage at the designated test points, similar to the previous step. If battery voltage is confirmed, it indicates that the +B in-J wire is operating correctly and that the pathway for power delivery is clear. Conversely, if no voltage is detected, it indicates an open circuit that must be addressed, pointing to a potential issue between the +B in-J wire and the injector relay or the associated fuse. In this step, you will assess fuse number A10, which plays a crucial role in protecting the electrical circuits pertaining to the injectors. Inspect the fuse located within the underhood fuse/relay box. If the fuse is found to be blown, it must be replaced to restore circuit integrity. If the fuse is intact, the next course of action will involve checking for shorts along the wiring leading to and from the fuse. Confirming the condition of this fuse ensures the safety and reliability of the injector circuit by preventing overload and potential damage. This step is focused on verifying the integrity of the INJ RLY clear wire. Begin by switching the vehicle to the on mode while the injector relay remains disconnected. Measure the voltage at the specified test points. The presence of battery voltage confirms that the connection is intact momentarily after switching on the vehicle, indicating that the electrical signal is being transmitted effectively. Should there be a lack of voltage, it will necessitate further investigation into the potential open circuit within the INJ RLY clear wiring, which would require repair. In this step, you will perform a continuity check on the INJ RLY clear to ascertain if it is intact. Begin by turning the vehicle to the off/lock mode and disconnecting the specified PCM connector and injector relay. Check for continuity between the designated test points. If continuity is confirmed, it suggests that the INJ RLY clear operates correctly. If there is no continuity, you will need to identify and repair the open circuit between the PCM and the injector relay. This ensures proper communication and functionality of the injector circuit. Step 9 involves verifying the INJ RLY line for any problems. First, ensure the vehicle is in the off/lock mode and connect the specified terminals with a jumper wire. After establishing the connection, check for voltage between the designated test points on the PCM connector and while the injector relay is disconnected. If battery voltage is present, it confirms that the pathway is functioning correctly. Conversely, if no voltage is found, it suggests issues with the wiring that needs repair between the PCM and the injector relay. ensuring reliable operation of the injection system. At this stage, check for the presence of DTCs again to determine if P0201 is indicated. This crucial step allows you to reassess the situation based on any previously identified issues. If DTC P0201 appears, further diagnostics can proceed to the next phase, examining potential wiring problems specific to the number 1 cylinder injector. On the other hand, if P0201 is not displayed, the matter may involve intermittent issues, potentially pointing to transient failures or connections that need further examination. This step revolves around checking the continuity of the INJ-H1 and INJ-L1 wires. First, ensure the vehicle is in the off-lock mode and disconnect the appropriate connectors. Measure continuity between the terminals specified. If continuity is confirmed, it demonstrates that both wires are intact and able to transmit signals as needed. If there is a break in either wire, urgent repairs must be made to restore functionality. This step is critical in identifying faults within the circuit that could lead to injector malfunctions. Step 12 calls for another continuity check, now specifically on the INJ-H1 line. Disconnect the number 1 injector and measure continuity between the designated test points. If continuity exists, then the INJ-H1 wire is functioning correctly. However, if continuity is absent, it highlights a problem that needs addressing, particularly between the PCM and the number 1 injector. Exploring this potential fault is vital for confirming the operational status of the injector circuit, ensuring seamless engine performance. The focus of Step 13 is to verify the integrity of the INJ-L1 line through continuity testing. Inspect the connections and ensure your vehicle remains in the off mode while conducting the test. Check for continuity between the specified points involved with the INJ-L1 circuit. Confirming continuity here indicates that the circuit is healthy. Is not. This would suggest an issue that should be rectified, indicating potential disconnections or breaks that affect performance. Addressing these matters ensures effective fuel delivery and injector operation. In this step, you'll examine the INJ-H1 line for potential shorts to power. First, disconnect the necessary connectors and turn the vehicle to the on mode. Measure the voltage between the designated test points. If voltage is found, this signifies that there is a short to power within the INJ-H1 wire that needs repairing. Conversely, if no voltage is discovered, it suggests the wire is in good condition. This step is significant in verifying that the integrity of the circuit is maintained without unintended connections, which could compromise injector functionality. Step 15 requires examining the INJ-L1 wire for any short circuits. Begin by ensuring the specified components are disconnected and switch the vehicle to the on mode. Measure the voltage at the designated test points. A reading of voltage confirms a short in the INJ-L1 wire that needs immediate attention. If there is no voltage, it indicates that this wire is functioning appropriately. It is essential to continuously monitor wire integrity throughout the troubleshooting process to prevent further complications within the injector circuits. In this troubleshooting step, focus on conducting a continuity check within the INJ-H1 wire. While the vehicle is switched to the off mode, ensure the appropriate connectors are disconnected and check for continuity between specified test points. If continuity is confirmed, this indicates the INJ-H1 wire is functioning properly. If absent, it requires immediate examination and repair of the wiring issue. This step is pivotal in ensuring reliable fuel injector functionality, as breaks in the wire can lead to unpredictable engine behavior. Step 17 involves checking the INJ-L1 wire for continuity to ensure its integrity. This involves disconnecting specific connectors and confirming continuity between designated test points with the vehicle in the off mode. If continuity is affirmed, it shows that the wire can function correctly, while a lack of continuity necessitates repairs. This assessment is critical in verifying the complete operational status of the injector circuits. A faulty wire can pertain to persistent DTC issues and should be rectified promptly. In Step 18, the attention shifts to checking continuity of the INJH4 line. You'll need to ensure specific components are disconnected and maintain the vehicle in the off mode during testing. Measure for continuity between specified test points. If continuity is present, it indicates the INJH4 wire is healthy. Conversely, a lack of continuity will point to an open circuit that must be addressed. This aspect of testing is vital for ensuring efficient fuel injector function, as any failures could lead to engine performance issues and error code persistence. Step 19 focuses on checking for any open circuits in both the INJH4 and INJL4 lines. Ensure the vehicle is in the off mode and that relevant connectors are disconnected. Measure continuity across the respective test points. If continuity is established, both wires are functioning correctly, allowing the necessary signals to reach the injectors. Should continuity be absent, it would indicate an open circuit, necessitating immediate attention to restore operational integrity. Understanding this step allows technicians to maintain the reliability of the injection system. At Step 20, the task is to check the continuity of the INJH4 line. You should disconnect the number 4 injector connector and ensure the vehicle is off while measuring between the specified test points. Confirming continuity indicates a functioning wire. If checks fail, repair any open conditions between the PCM and the number 4 injector to restore the circuit. This checking helps maintain the overall efficacy of the injector circuits, which is vital for optimal engine performance. In troubleshooting Step 21, focus on verifying continuity in the INJL4 line. Ensure all relevant components are disconnected and the vehicle is turned off. Measure for continuity between the designated test points. If confirmed, the wiring is operational, allowing proper signal transmission to the injector. However, if no continuity is demonstrated, it suggests the presence of an open circuit that will need to be repaired. This step confirms the integrity of the circuit necessary to effect reliable injector operation. Step 22 calls for checking the INJH4 wire for shorts to power. Disconnect the relevant connector and turn the vehicle to the on mode to initiate a voltage measurement. If voltage is detected, it indicates a short to power that must be repaired. Conversely, a lack of voltage confirms proper wire condition. This troubleshooting is crucial in preventing electrical issues that may compromise injector performance and vehicle operation. Monitoring the health of these wires facilitates safe and effective operation of the Honda CRV's fuel system. Proceeding to Step 23, the focus is on the INJL4 wire and its potential for shorts to power. Begin by turning the vehicle to the on mode and measuring the voltage at the specified test points. A detected voltage signifies a short that must be addressed. However, if the voltage is not present, it indicates that the wire is functioning correctly. Attention to wire integrity in this aspect is critical for the reliable operation of the injectors, affecting overall engine performance and responsiveness. In Step 24, the focus is on ensuring the INJH4 line is clear of shorts. Begin by turning the vehicle to the off mode and checking continuity between the designated test points. If continuity is confirmed, it indicates that the circuit is secure and functioning as expected. Failure to find continuity will require further investigation to rectify potential issues in the wiring. Ensuring circuit integrity supports the effective operation of the injector system, which is vital for maintaining optimal vehicle performance. Step 25 is dedicated to checking for shorts in the INJ-L4 wire, with appropriate connectors disconnected and the vehicle off. Continuity should be measured between the designated points. Establishing continuity suggests the wire is functioning correctly, while a lack of it indicates the need for repairs within the circuit. This check is essential in ensuring that the fuel delivery system operates without fault, directly affecting engine functionality and performance. The final step involves checking for shorts in the INJ-H1 wire. As with previous steps, ensure the vehicle is off while testing for continuity. By measuring between the designated test points, you can verify the health of the wire. Should continuity exist, it suggests proper wiring is in place for injector operation. Absence of continuity necessitates immediate action to rectify the fault, ensuring the injector circuit can operate flawlessly. This step completes the troubleshooting process, reinforcing the critical need for electrical integrity within the system. Final verification of repairs is necessary to ensure DTC P0201 and P0204 are addressed effectively. After verifying and rectifying all potential issues, clear the DTCs using the Honda Diagnostic System, HDS, to reset any fault codes. Following this, perform a test drive to observe the vehicle's performance under real-world conditions. Monitoring the vehicle for any reoccurrence of symptoms will validate the efficiency of the repairs made. Consider this final step an essential quality check, guaranteeing that the igniter circuits are functioning optimally. Preventive maintenance is vital to avoid future issues related to DTC P0201 and P0204. Regular inspections of wiring connections and the injector relay can help identify potential problems before they escalate. Implementing routine checks on injector performance ensures that fuel delivery is consistent and efficient. Keeping connections clean and free of corrosion or wear is equally essential in maintaining the integrity of the electrical system. Adopting a proactive approach can mitigate the risk of encountering these error codes again, enhancing overall vehicle reliability. In conclusion, understanding the symptoms and implications of DTC P0201 and P0204 is critical for effective troubleshooting. Implementing a systematic diagnostic approach allows for thorough investigation of all potential causes, from faulty wiring to relay issues. Regular vehicle maintenance, including wiring inspections and connection checks, plays a pivotal role in preventing such errors in the future. By being diligent and proactive, vehicle owners can not only resolve existing DTCs, but also enhance the long-term reliability of their Honda CRVs. Restoration of confidence in vehicle performance is key to enjoyable and hassle-free driving. Please like and subscribe to the channel. See you next time.